Hi everyone, Chapter 9 is called Estimating the Value of a Parameter, but the main topic it covers is confidence intervals. And the first section covers estimating the value of a population proportion, and it's mainly about finding the confidence interval for a population proportion. We'll start off with an introductory example, and in this example, it's going to look at a way to estimate the proportion of students who carpool. Suppose that you're a research analyst for Omnitrans and you wish to estimate the population proportion of students at Chaffey College who commute by bus on a weekly basis. So if you are conducting this study, the first thing that you would need to do is to survey a sample of students, get the results, and then summarize those results. Let's say that you obtain a random sample of 400 Chaffey College students, and you ask each student in the sample whether or not they commute by bus on a weekly basis. And you get these results. You find that 86 out of the 400 students respond that they commute by bus on a weekly basis. So based on those results, you can calculate what's called a point estimate. A point estimate is just the result of your study, and in particular, this point estimate is called the sample proportion. It's an estimate of what the proportion is of the number of students who carpool. The sample proportion is symbolized as a P with a little hat on top. It's called P hat. And P hat is found by taking the number of yes responses. In this case, 86 said that yes, they carpool, they commute by bus on a weekly basis. And N is the sample size. So 86 divided by 400 comes out to 0.215, or converting that to a percentage, that's 21.5%. So note that this entire first step is involving descriptive statistics. And in particular, this study is an observational study. The next thing that you would need to do is to calculate what they call the margin of error, and then construct a confidence interval to estimate the population proportion. Remember that P hat is a point estimate. It's just summarizing the results of your 400 student sample. But your ultimate goal is to estimate P, and P represents the actual population proportion of students at Chaffey College who commute by bus on a weekly basis. This is not known. This is what you're trying to find out. What's the actual proportion among all of Chaffey College students, not just among the small sample that you took. So to estimate the population proportion, the first thing that you'll need to do is calculate the margin of error. Let's say that for your margin of error and for your confidence interval, you want it to have 95% confidence. And in just a moment, we'll talk about what confidence means. But for now, let's just suppose that you want to have 95% confidence. To calculate the margin of error, you would use this formula. The P hat is our sample proportion, so 0.215 is what you put in for P hat. N is the sample size, so 400 would go here. But what about this right here? This is called Z sub alpha over 2. Another name for it is critical Z value or cutoff Z value. So, just a moment ago I mentioned that you want to have a confidence interval with 95% confidence. The meaning of that is that your confidence interval is going to be based on the middle 95% of a standard normal distribution. The z sub alpha over 2, these values, they represent the cutoff z values for the middle 95%. So here's a standard normal distribution. Let's suppose that this shaded part is the middle 95% of the curve, and the cutoffs for those would be z values, the actual values that are on the x-axis. One way to find the value of these cutoff z sub alpha over 2's is to use a table that's provided in our book. It's called Table 5b, and you can find it at the bottom of Table 5. So here's Table 5. At the very bottom, you'll see it, Table 5b, and you'll look up the level of confidence. So you want to have 95% confidence, and for that, the critical values for z are 1.96. Now, there's all that is needed to put into the formula. We'll put in 1.96, put in all the values for p hat and n, and it comes out to about 0.0403. That's the margin of error. So that means that the margin of error is 0.0403. Remember that here we're talking about percentages and proportions, so you can convert that to a percentage, and that's the same as saying 4.03%. The meaning of a margin of error is that if 4.03% is the margin of error, you have high confidence, in this case 95% confidence, that the true proportion could be as much as 4.03 percentage points higher or lower than the point estimate. The last thing is, now that you have the margin of error, you can calculate the actual confidence interval. The 95% confidence interval for the population proportion can be found using this formula. P hat is the 0.215. The E, the margin of error, is what you just calculated. It's P hat minus E for the lower bound, P hat plus E for the upper bound of your interval. And you work that out, and that comes out to 0.1747 for the lower bound and 0.2553 for the upper bound. So just to emphasize, this is the lower bound. This number is the lower bound of your interval, and then this right here would be the upper bound of your interval. So to conclude, we just found that the 95% confidence interval for the proportion of students at Chaffey College who commute by bus on a weekly basis is this interval, or we can convert it to a percentage because we're talking about proportions. The last step would be to interpret that confidence interval. How would we interpret this? Well, one way to interpret a confidence interval is something like this. We could say we are 95% confident that the population proportion, P, of students at Chaffey College who commute by bus on a weekly basis is between 17.47% and 25.53%. you can word your interpretations differently if you wanted to, but however you describe your confidence interval, it's a good idea to mention these three things. You want to mention your level of confidence, you want to mention the population proportion, or what you're actually estimating, and then you'll want to mention the actual interval. One last note before moving on to the next topic is that steps 2 and 3 of this problem both involved inferential statistics, because in these steps you were using the results of your sample. The result was this p hat. You calculated a margin of error, and you used that to draw a conclusion about the entire population of students. All right, in the next video, we'll take a look at confidence intervals more generally.